Hello guys, thanks for coming, my subscribers. And if you're new on this channel, please click on the subscribe button and also on the bell beside it. That will notify you when we drop our wonderful videos. Now, in this video, we want to look at tabular form of solving integration by part. Actually, when you see questions like this, what next comes to your mind is you make use of this particular integration by part formula, which says the integral of this is going to be uv minus integral of v du. Good. That is what comes to your mind. But we have a easiest way for doing this. Very, very easy way, and it's a tabular way. So probably we just try to apply that, and you can try to use this method yourself to get the same answer with the one I'm about to use now. Okay, let's try the tabular form and see how it goes. Now we have this is the integral of x squared e raised to power x dx. So what next? I will draw my table. My table have three columns. So I have the sign, the differentiation, and I also have the integration. So what next? My sign started from positive, negative, positive, negative, and so on. So let me stop here first. So now this first part of the integral, which means this term x squared, I'm going to place it here, x squared. I'm gonna place the e raised to power x at the integral side. So I have e raised to power x. So what I will do now is I will continue differentiating this until I have 0. So if I differentiate this, and I will continue integrating this, the limit here is when the derivative is 0. So I stop. Then I'll continue the integral. So once it has reached a point where the derivative is 0, then I'll stop the integration as well. So which means I will find the derivative of this to get 2x. For that derivative, I'm going to get what? 2. And the last derivative, I'm going to get 0. So which means I am going to perform integration 4 times. I mean 3 times, just like the way we perform this. We perform differentiation 3 times. That is 1, 2, 3. So which means I'm going to perform integration 3 times as well. So the integral of e raised to power x, remind me, it's e raised to power x, e raised to power x, and e raised to power x. So what next? To get our answer, don't forget these signs are important and we're going to make use of them right now. So this sign multiplied by this, then multiply by this, which means the integral of x squared e raised to power x dx will now be this positive multiplied by this. So I have x squared e raised to power x. Then I will add that with negative this. So this goes with this, then negative. Actually, the sign here is going to be negative. So let me put that minus 2x e raised to power x. Then I move on with positive. So and this goes with this. So then I have plus 2 e raised to power x. So which means my answer is going to be x squared e raised to power x minus 2x e raised to power x plus 2 e raised to power x plus c. So that is the integral here. That is the tabular form. And if you try the uv minus integral of v du, you will definitely get the same answer. Okay, I'm going to solve another complex question with this and see how it goes. Okay, let's look at this using the same tabular method, and you can I tell you about it, you can actually try this yourself. After some minutes, I will give you a certain chance to try this yourself, so then you can pause the video, try yourself, and see, probably get the same answer. You can also use the uv minus integral v du and tell your answer, compare the answer, it will definitely be the same. So now let's look at this now. To solve this, I told you I have my sign in the table, I have my differentiation, and I also have my integration. So then the positive sign, negative sign, positive, negative. So you can predict the number of positive, negative you can have as a result of the derivative of this. And I think you should be able to perform about 4 or 5 derivatives here. So I have x raised to the power 4 and I have sine x. Okay, so now let's proceed with this. If I have the derivative of this and that gives me 4x cubed, and I differentiate that one more time, I'm going to have 12x squared. I differentiate that one more time, I'm going to have 24x. Then I differentiate one more time, this sign here is going to be positive, and then I'm going to have 24. So then the last time I'm going to differentiate now, I'm going to have a negative sign, and that will be 0. So now I can start integrating this. If I integrate sine x, I'm going to get minus cos x. Then if I integrate minus cos x, I'm going to definitely get minus sine x, because you can perform the integral of cos x dx, so and that is negative. So if this is negative, you can separate the minus from the integral. You have cos x, the x, and this gives us sine x. So then you have minus sine x. Then perform the derivative of minus sine x, you definitely get cos x, because if you separate the integral, you're going to have integral of minus sine x, the x. So, and moreover, this becomes minus integral of sine x. Like I've said, the integral of sine x gives cos minus cos x. So the positive, the negative signs will multiply each other. So we get what? We get cos x as it is. So then we perform the integral of cos x again. So when we perform the integral of cos x, what are we going to get? The integral of cos x then will give us sine x. And then the integral of sine x one more time will give us minus cos x. So I think we stop the integration since we've gotten to the 0 part. Then we continue with multiplying by the x. So what's next after this? What is next? So then I go along with the multiplication. So then I have this, I have this, I have this, and lastly this. So which means the sign multiplies this. So I will write to integral of x raised to the power 4 sine x. The x will now be equals to positive x raised to the power 4 times negative cos x is going to give me minus x raised to the power 4 cos x. Then I'll go ahead with this. So minus 4x cubed times minus sine x. I'm going to have positive 4x cubed sine x. Then I proceed with positive 12x squared times cos x. So I'm going to get 12x squared cos x. Then I proceed with 24, and that is negative. So which means I'm going to have, actually this is a continuation of this, so you can actually probably write it in a straight line. So, and I have 24, so that is going to give me minus 24 sine 24x rather, sine x. Then I have the last one, okay, sorry, 24x. So then I have positive, so then plus 24 cos x. So let me write in full for you guys. So integral of x raised to the power 4 sine x dx will now be equals to minus x raised to the power 4 cos x plus 4x cubed sine x plus 12x squared cos x minus 24x sine x, and lastly plus 24 cos x. You can try that using uv minus integral v du. You definitely get the same answer. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.